Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. The Kessler syndrome. Multi-orbit satellite constellations as triggers of space debris cascade chain reaction. Kessler syndrome chain reaction, a hypothetical collisional cascading scenario where the density of objects and space debris in low Earth orbit reaches a critical point, such that collisions become self-perpetuating, creating a cascade effect that generates more space junk, eventually making certain orbital regions unusable for future space activities. Due to the exponential increase in the number of mega satellite constellations, such as SpaceX Starlink and Amazon Kuiper, and increased interest in multi-orbit satellite constellations, there is a possibility of the risk of triggering the Kessler syndrome. The Kessler syndrome unfolds as a domino effect and feedback runaway effect, where high-velocity collision impacts between objects of sizable mass spall of debris from the force of the collision, leading to the formation of fragments which can hit other space assets, leading to more space debris. If the rate of debris creation surpasses the rate at which it naturally deorbits due to atmospheric drag, a self-sustaining feedback runaway chain reaction occurs and creates a dense permanent bed of debris in that orbit. Multi-orbit constellations could lead to Kessler syndrome by significantly increasing the density of objects at various orbital altitudes, thereby escalating the risk of a chain reaction of collisions that generates even more debris. Although a full self-sustaining Kessler syndrome chain reaction has not occurred yet, several major incidents demonstrate the underlying principles and risk of such an event. Examples are many Kessler events, including the 2009 Iridian Cosmos collision, anti-satellite tests, explosion of spent rocket stages, and a host of others. The focus points are as follows: Kessler syndrome technologies disruption, multi-orbit satellite constellations Kessler syndrome triggers, and Kessler syndrome mitigation strategies. Kessler syndrome is a hypothetical scenario in which the density of objects in low Earth orbit becomes so great that collisions between objects create more space debris, setting off a chain reaction of destructive impacts. The cascading process could potentially make space exploration and satellite use unfeasible for generations. The proliferation of debris poses significant risk to satellites, space missions, and the International Space Station, potentially rendering certain orbital regions unusable. Illustration of the proliferated constellation is shown in this picture. Anti-satellite missiles. In 1985, the first anti-satellite missile was used in the destruction of Sunwing P781 satellite. On 11th January 2007, China conducted an anti-satellite missile test in which one of their FY-1C weather satellites was chosen as the target. The destruction of the Cosmos 1408 satellite by a Russian assault missile on November 15, 2021 has created a large debris cloud. The resulting debris from the use of the anti-satellite missiles will likely remain in orbit for decades or centuries. Illustration of low Earth orbit satellite constellation is shown in this picture. Kessler syndrome technologies disruption. Kessler syndrome could disrupt numerous critical technologies which rely on low Earth orbit satellites, affecting a wide range of everyday services and industries, such as communications, navigation and timing, Earth observation and monitoring, national security, and space exploration. Illustration of the next generation of space traffic management for preventing Kessler syndrome is shown in this picture. Communication technologies at risk. Internet and Wi-Fi. Widespread outages of satellite-based Internet and Wi-Fi services, including large constellations such as SpaceX Starlink, are crucial for connecting remote and underserved areas. Telecommunication disruption of cellular networks, phone services, and long-distance radio television broadcasting, which rely on satellite backhaul and transmission. Also, emergency response. Eutelsat multi-orbit GeoLEO satellite network is shown in this picture. Another Kessler syndrome disruption is in navigation and timing technologies at risk, such as global positioning system and aviation logistics. While core GPS satellites are in MEO, systems in LEO provide supplementary data and increase accuracy, and a dense LEO debris field will make access to space difficult for replacement or maintenance missions. Telesat Lightspeed Constellation is shown in this picture. Other navigation and timing technology at risk are maritime and land transport, and financial services and utilities. Illustration of satellite coverage for telecommunication service is shown in this picture. National security and space exploration technologies at risk are military operations and future space access. Defense sectors worldwide depend on LEO satellites for intelligence, surveillance, reconnaissance, and secure communication. Their loss will severely impact strategic capabilities. A severe Kessler syndrome event will make launching new satellites and conducting crew missions extremely dangerous. Orbital design optimization for large-scale side constellation is shown in this picture. Multi-orbit satellite constellations Kessler syndrome triggers are crowded orbits. Multi-orbit constellations, especially mega constellation in LEO, introduce thousands or 10,000s of new active satellites. Overlapping paths. By design, these constellations often inform multiple orbital planes, which could cross at high relative speeds. Illustration of the use of AI in transforming geospatial intelligence is shown in this picture. Collision and debris propagation, high velocity impacts, and cascading effect. Objects in orbit travel extremely at high speeds, about 28,000 km per hour in LEO, which implies that small fragments from a collision can cause catastrophic damage. A single major collision or fragmentation, in the case of anti-satellite tests of field disposal, generates thousands of new untractable debris spaces. Satellite constellation for mitigation of environmental and other effects is shown in this picture. Kessler syndrome mitigation strategies are collision avoidance, post-mission disposal, and design for demise. Designing satellites that completely burn up during atmospheric re-entry minimizes the amount of debris that could reach the ground or persist in orbit. Illustration of satellite mega constellation is shown in this picture. Policy and regulatory measures are international guidelines and standards, licensing and regulation, and data sharing and space traffic management. Versatile space-related communication concept for multi-orbit mission is illustrated in this picture. Design and technology solutions, onboard propulsion for collision avoidance, and post-mission disposal systems. For control re-entry, satellites should be designed to perform a control re-entry into the atmosphere. And for the graveyard orbits, for satellites in higher, less crowded orbits, moving them to designated graveyard orbit after mission. ESA's multi-orbit concept of next-generation communication is shown in this picture. For more information, contact Astronautics for exploits. You've been listening to the Kessler syndrome, multi-orbit satellite constellations as triggers of space debris cascade chain reaction by Dr. Anyashola Ogundele, with the focus points Kessler syndrome technology disruption, multi-orbit satellite constellation Kessler syndrome triggers, and Kessler syndrome mitigation strategies. Thank you.